call. All the esteemed guests joining the call, key stakeholders, researchers, technology pioneers, policymakers, and experts on the call here. Thanks for joining us and truly making this a significant occasion. Not just because it is World Hydrogen Day, but also since we have, in our small way, tried to initiate by kickstarting the first edition of a hydrogen dialogue series, which we intend to continue in an ongoing manner and bring many more interesting topics. Today, we're not just here celebrating a molecule, the first one in the periodic table, but we are also here to discuss the role of hydrogen as a strategic fuel that will define the next chapter of global energy. Today, as we see, the world stands at a very critical juncture. It faces multiple challenges, predominantly with the rapid push for decarbonization and the kind of volatile geopolitics that we are seeing, wherein the traditional energy security is being challenged, and there's a new global energy race. India has an ambitious pursuit to be a green hydrogen leader, and this is a direct and strategic response that is vital, not just for our climate commitments, but also for achieving energy independence and driving zero emissions initiatives. As an ecosystem enabler, we at Rich, in collaboration with industry partner Jindal Stainless, are delighted to host this pivotal webinar titled Green Hydrogen in India, Addressing Challenges in Value Chain Through Innovation and Collaboration. The title says it all, that we intend to bring multiple such sessions which will help in addressing the challenges in value chain through innovation and collaboration with all the key stakeholders. We are here to translate policy into actionable innovation. And this webinar is designed to initiate conversations among key stakeholders and bridge the gaps, particularly in indigenization of technology, value chain integration, and driving collaboration and encouraging investments, which will eventually help in achieving the scale and costs necessary to compete globally. Over the next 90 minutes, our esteemed speakers will deliver crucial knowledge on topics that form the backbone of hydrogen future. We will be covering, starting off with the global demand factors which govern the global demand for green hydrogen and its derivatives and the opportunities it poses for India. We'll look at the essential steps for localization of electrolysers and production of other components through our peers at L&T. This will ensure a resilient and sovereign supply chain. Further, we are going to look at the crucial role of advanced materials such as stainless steel, which help in guaranteeing a safe, durable, and reliable supply chain for hydrogen. Finally, we'll also look at what are the practical steps that are needed to bring the cost of hydrogen below 300 rupees a kg. This is extremely crucial for making green hydrogen economically viable and achieving the scale that is required to replace the other sources of energy in the industry. I'm confident that the insights and global best practices and networking opportunities generated today will be instrumental in forging strategic partnerships needed to realize India's hydrogen vision. Thank you again, once again, for joining this webinar. And with this, let the dialogue begin. I'll start off by introducing the presenters for the day. We have Karan Arora from GIZ, who will be coming in and focusing on global demand centers for green hydrogen and its derivatives, followed by Mr. Siddharth Gupta, CEO for L&T Electrolysers, who will be focusing on sustainable hydrogen supply chain and localization of electrolysers. Then we have Mr. Varun Prudhi from JSL Jindal Stainless, who will be focusing on materials, novel materials such as stainless steel for hydrogen value chain and its applications. And finally, we would be the presentation from Himadri Singha from Deloitte, who will be focusing on cost reduction pathways for bringing green hydrogen under rupees 300 per kg. Now, I would like to invite Karan to maybe give a brief introduction and get started for topic of the day, that is, green hydrogen, global demand for green hydrogen, its derivatives, and what opportunities it offers for India. Karan, over to you.
Thank you, Mr. Srinivas. And first of all, thank you to Research and Innovation Circle of Hyderabad and Jindal Stainless Limited for making sure that on 8th of October, which also happens to be directly linking to the atomic weight of hydrogen AMU of 1.008. So it's a very important date, and congratulations for this first webinar series, the first dialogue today. So let me just share my screen. I hope it is visible now.
Yes.
Great. So thanks for this kind introduction. And yes, I am Karan Arora, Energy Advisor with GIZ India. So for those who don't know, GIZ is commissioned by German government to support countries, including India, by providing development assistance. So our main partners being MNRE, Ministry of Power, MOE, FCC, and other ministries in central government. So primarily GIZ is working in 4 broad areas like energy, sustainable development, urban development, skilling, and health. So today, as Mr. Srinivas talked, I'll be talking about where this global hydrogen market is heading to and how India and especially also Telangana can grab this opportunity. So GIZ is supporting transition through Indo-German cooperation programs. And our work on hydrogen is anchored in these 2 projects, what you see, hydrogen ramp up program and green hydrogen investments. These are backed by Federal Ministry for Economic Affairs and Energy, BMWE, and BMZ, Ministry for Economic Cooperation and Development. Talking specifically about green hydrogen investments, so this project is especially focusing on hard to abate sectors. And I'm especially delighted to also have the Jindal Stainless also a part of this dialogue. So this project is directly contributing to hard to abate sectors like steel and fertilizer. So yes, steel is one of the sectors, and this project is supporting the decarbonization in the steel industry as well. And talking about hydrogen ramp up, so these projects are usually export oriented. So the projects are promoting public private partnership along with the German counterparts. And what has happened so far in India are these projects, what you see, the first one being with RWE on hydrogen exports, especially green ammonia from India to EU through the seaborne route. And the second one being export of green methanol, which is being done with Renew and 3E. So there are, you see that one company is usually the German company, and they are partnering with an Indian counterpart. And obviously, It is backed by Ministry of Economic Affairs and Energy. And the another ongoing project is with European Energy Exchange from the German side, along with Indian Gas Exchange, hydrogen trading platform. And the last one, which is ongoing, is the hydrogen market entry strategy for ThyssenKrupp Nucera. So this obviously shows that yes, India is being looked upon quite seriously and as a promising partner for hydrogen development. And as you see, these are the hydrogen ramp up program countries, and India is one of them. And these are the PPPs which are ongoing in other parts of the world. And yes, India stands out with the advantage of private sector momentum and scale of opportunity. And last year, this happened when Minister Robert Habeck from Germany had visited during the seventh intergovernmental consultation. It was the seventh IGC, and that's when a very huge milestone of Indo-German green hydrogen roadmap. It was exchanged between the minister from Germany and Indian Minister Piyush Goyal. It was in the presence of Chancellor Olaf Scholz that time and Prime Minister Modi. So this cooperation is in technology, certification, and market development. So this is aligning very closely to the India's national green hydrogen mission of and also the target of 5 million metric tons per annum by 2030. And on the ground, activity is booming. You see a lot of projects have been announced, more than 150 so far. And if you talk about on a global scale, we always hear about NEOM and projects in Europe. But it is surprising that, yes, some of the largest green hydrogen projects globally are currently being developed in India. We also see a few projects from JSL here, the one in Hisar, along with Hygenco, an initiative taken for decarbonizing their steel production. Another one from them is in Odisha. And yes, we have seen a lot of MOUs being signed by the companies like Semcorp, AM Green with Uniper, RWE, BASF. So in one of our studies, which I highlighted before, which was done with RWE, we have identified that India is obviously one of the largest gray hydrogen consumer, and we already have a lot of ammonia import terminals. But there is also an opportunity that there are 14 possible export hubs which we have identified, and a huge potential for exports is coming out of India. And one of the initiatives was to map these demand centers with supply centers. So this is the dashboard h2hubs.in, one of our effort to map these demand and supply centers. So this tool is being further developed. So currently we had mapped up a few sectors, hard to abate sectors, especially where because there is a lot of gray hydrogen demand currently in these sectors, like in fertilizer refinery. So what will be the future 2030 scenario? What does the green demand look like? So this has been mapped in this dashboard, and now we are also trying to bring in more sectors like chemical, glass. We are bringing in ports. What is the electrolyzer requirement in such areas? So that is being further developed, and most likely it will be launched by next month. And another scenario in this dashboard is the RE, which is offered in certain hydrogen hubs. So this is also being mapped up, and obviously the possibility of taking out export of reports and Excel files out of these. You can play around, select your scenarios, and make a report out of it. And talking about India, India's renewable advantage is unmatched. So you see a continuous solar profile over 365 days. And when you compare it with Germany, so the variation in India, minimum to maximum, is just 2, whereas it's, in Germany, it's 32. So even the worst day in India is one of the best days in Germany. So this is unmatched, and this complemented with a good wind profile. When the sun is not shining, so we have the wind which is blowing, and also during the evening, late hours, during the specific months that we want. All this translates to one of the most competitive RE prices in the world. And we have got all the ingredients, including the 5,000 kilometer of coastline, which gives the access to the abundant seawater, then which can be desalinated and run the electrolyzers for producing these molecules, is also tremendous. So I must say, so we've got all ingredients for low cost hydrogen, ammonia, derivative production. Now, the question is, can this be translated from ambition to trade? So in this global map, you see the major demand centers: Europe, Japan, South Korea. So what do the demand in 2030 look like in Europe? It's 20 million metric tons, which has been announced, 10 domestically, 10 through imports. And here you also see countries which are dark shaded, dark blue, and these are the countries where the export, they consume less as compared to they can produce potential production. India is placed at a neutral level, so we have huge demand domestically, but we also can cater along with Australia and the MENA region that you see, which has a good potential to export these molecules and bridge the import, this gap in which is arising in Europe. The role of Germany and the relationship of Germany is threefold in India. India is seen as exporter, and it is also seen as a technology importer for how the technologies for electrolyzer and production of hydrogen is concerned. So we are also looked upon as a technology transfer player, and what our effort through the knowledge exchange partner is while we can produce these molecules at a competitive price, and the project has to be bankable, but at the same time we also have to ensure these are compatible and are certified as per the EU RFNBO, renewable for non-biological requirement that has set by EU. So this has been our effort to bridge the India certification scheme with the EU RFNBO methodology through certain white papers. So you see that the German companies are interested in India. We had a directory, we are updating it too. So here one can find the interested German companies in India who want to venture, like you see the fuel cell manufacturer SFC producing fuel cell along with FCT, the Indian counterpart, in Gurgaon. So the fuel cells are through German technologies are getting manufactured in Gurgaon. ThyssenKrupp has opened an office in Mumbai, and they are quite active. RW is taking 250,000,000 tons of green hydrogen, ammonia derivatives from AM Green. So it looks exciting. And I talked about the one of the initiatives, which was the public-private partnership project between European Energy Exchange and Indian Gas Exchange. I wanted to emphasize on that. Yes, like we have electricity exchange, we have natural gas exchange. The idea is also to have another molecule in this portfolio, which is going to be a green hydrogen trading platform, which can ensure that we match make the producers with the consumers. And our initiative, the aim is to gather market insights and engage with the stakeholders right from the production to consumption, including the regulators. All it takes to make this price index and trading service possible is the initiative which is ongoing. We are having a series of workshops, stakeholder consultations. So this is another promising piece coming up. And talking about Research and Innovation Circle Hyderabad. So along with Rich, we also did a roadmap for green hydrogen cluster. So we worked with Telangana, we worked with Kerala in Kochi, developed a green hydrogen roadmap, what it takes, because these clusters offer a good industrial mix. We have fertilizer companies, we have cement, glass, and refineries in Kochi, which can obviously offtake these hydrogen production, and making them an ideal candidate for India's hydrogen valley. Talking about the global demand scenarios, like we have demand aggregation and tenders coming from SECI in India. Similarly, on global scale, Hintco is doing from Germany global procurement. First round was successful where Fertiglobe had won the tender for green ammonia, supplying 397,000 tons for 7 years. Now the second round has passed the application phase, which is on the regional lots. So there are regional lots allotted, and one of the regional lot is Asia window. And in Asia window, obviously, Indian companies are actively participating. We see a lot of Indian companies, participating in these tenders for green ammonia, green methanol, sustainable aviation fuel. And the good news is the funding has been increased to 580 million euros for 10 years, while S2 Hintco is, assuring the supplier 10 years purchase on the supply side, and on the demand side they are going to do another round of auction on a short-term basis, and the gap between the supply and demand will be funded through this 580 million euros, which is being made available by the government of Germany along with the Dutch government. And again, there will be another pilot lot which is going to be reopened. There will be a pilot auction for that as well.
Just a quick time check that. Okay.
Sure. This is the final 3 slides that I'm going to take up. Another
Sure.
thing which was done up was the PTX Development Fund. Again, this is the second round, and a lot of Indian companies, we see a lot of excitement from the Indian players. The Viability Gap Fund of 30 million euros, and the results are going to be announced most likely within a month or so for this fund as well. And why I talked about the opportunities for India, let me just also talk about green shipping, which is another area that we feel is going to be quite exciting for India, because of the legislation in EU maritime legislation starting this year onwards. There are GHG reduction targets which has been set into place. Irrespective of the flag of the ship entering EU, it has to comply to this target. So what is the opportunity for India here is the opportunity for refueling in India. So India can offer bunkering opportunities. These ports can offer methanol bunkering, ammonia bunkering in future. So this is again an exciting area where India has a lot of opportunity, being complemented with the IMO net zero fund, which is most likely going to be adopted next month. And this will again, it will be a GFI approach, GHG fuel intensity. So again, the ships will be required to transit to technology or fuel which is of a decarbonization nature. So there also we are seeing a lot of penalties coming into place, and India has a role to play here. So looking ahead, Europe's import demand for green ammonia and methanol creates a real opening for India, and India not only has the scale but also has the cost advantage. A little bit tweaking required in its certification, and double ledgers and double boundaries to be created by the developers and certifying bodies, so that they are good enough to be exported to EU market. And partnerships with the international cooperation, India, Germany, with government bodies, with rich leaders, industry leaders like JSL. I'm sure we will be a credible exporter in the 2030s. So that's it from my side. And if you have any questions, please let me know. Thanks a lot. And back to you, Mr. Srinivas.
Thank you very much, Karan. We probably have an opportunity to take 1 or 2 questions so as to be fair with everyone. We have given 20 minutes time slot. Yeah.
Sure.
Okay. I think in that case, we would proceed further with the next speaker. The next speaker in line is Mr. Siddharth. Mr. Siddharth Gupta, Chief Executive of L&T Electrolysers. And his topic for the day would focus on localization of electrolysers in general and supply chain for manufacturing of components related to equipment of green hydrogen. Siddharth, it is over to you now. I hope you're able to share your
Srinivas, just 1 minute. Mr. Gupta is joining.
Okay.
Yeah, he's here.
Okay. So you should be able to share your presentation.
Yeah, okay. Thank you, Mr. Srinivas, for this opportunity. And I'm just sharing my screen. Kindly give me a moment.
Sure, sir.
Is my voice audible?
Very much loud and clear, yes.
Okay. Thank you. Right, so can you see the presentation?
Yes.
Okay. So once again,
Yeah.
I'm thankful to the opportunity which is given to me. The topic which I was asked to deliver on the presentation is sustainable hydrogen supply chain, and basically talking about localization in electrolyzer production and addressing the reliability. So I feel there are two aspects which come out here very clearly, which talks about localization, and at the same time, from that localization, how the aspect of reliability gets introduced. Right. So I'll move ahead. Uh, well, as far as green hydrogen is concerned, I think the thrust really came from the government of India in terms of the National Green Hydrogen Mission. And there are three buckets, as you can see in the slide. The first one is manufacturing, second one is R&D, and the third one is development. So why manufacturing was placed as the first bucket in this is primarily because if you have a manufacturing value chain in India, which adheres to the concept of Make in India, uh, then you have indigenization, you have localization, which finally will result in reliability of the product and the whole ecosystem, which we will see as the presentation moves ahead. So there is a PLI scheme in manufacturing which was introduced as a part of the NGHM, which is the National Green Hydrogen Mission. The total incentives were in the range of around 4,500 crore rupees, which has been mentioned for electrolyzer manufacturers. And both the tranches have in fact been awarded to the various OEMs. I would also like to point out that L&T is one of those electrolyzer OEMs for 300 megawatt capacity, wherein we have been awarded this PLI. The second aspect bucket is research and development. Very importantly, in the case that you have a manufacturing ecosystem, I think you need an R&D setup, especially in this area, uh, in this niche area of electrochemistry, where you need to develop sort of, if you have the technology, develop on that technology and develop a self-reliance. So for that, there is a 400 crore R&D fund which has been given as a part of this mission, and there are various schemes within that. The third aspect is demand creation. And for any sector to thrive, as you would appreciate, it's very important that there is a demand in this ecosystem. By demand, I mean it's when the sector is starting up, which is green hydrogen, then it is necessary somewhere to create a demand for that. And so herein, the government had created basically as a part of NGHM, you had the overall binding figure that 5 million metric tons per annum of green hydrogen production will be achieved by 2030. So for that, again, there are incentives to the tune of 13,000 crore rupees, and with the vision that India will become a global hub for production, use, as well as export of green hydrogen, as well as its derivatives, which is ammonia, methanol, and others. So the total outlay, financial outlay, was around close to 20,000 crores, and the various elements have been enumerated here. I'll move to the next slide. As far as L&T is concerned, we ventured into electrolyzer manufacturing along this roadmap, which is shown here. We first set up a green hydrogen plant, basically as a proof of concept in August 2022, when the L&T management decided that green green hydrogen is the future, and we need to be ready for that. So they set up a green hydrogen plant, which was a proof of concept, where the green hydrogen which we were producing, we were blending it with natural gas in our furnaces. 15%, 10 to 15% was the blending ratio which we were using, and we've had satisfactory results from there. In March 2023, we signed a license agreement with a European company, McPhee. The foundation stone was laid, and very importantly, in December 2023, the first indigenous electrolyzer was manufactured and assembled in our factory at Hazira. Uh, March 25, what you see is the first commercial dispatch we have done for Deen Dayal Port Authority, Kandla. You can see 2.5 megawatt stacks and the DPA chairman and our team standing there in the close to the trailer where the sort of dispatch ceremony was organized. I'll move ahead. This is a snapshot of our manufacturing facility. Very happy to state that we have a completely automated stack assembly line, and the location is in Hazira, Gujarat. We currently have a capacity of 400 megawatts, and we are doing the stack and the EPU in our factory, and the technology is pressurized alkaline technology. On the bottom side of the slide, you can see the integrated green hydrogen plant, which I had mentioned in my earlier slide. This is spread over an area of 3,000 square meters, where we have put 2.5 megawatt stacks, which makes it 1 megawatt capacity, which is equal to 200 normal meter cube per hour of green hydrogen. And the application is we are blending 15% along with natural gas in the furnaces, which is used for heat treatment. Now coming as far as the approach for indigenization is concerned, again, very happy to state that as L&T Electrolysers, we've achieved more than 85% indigenization, which I think is a big achievement as far as the landscape is concerned. And we followed a very structured methodology, while going ahead with this indigenization program. The first two elements are vendor development and vendor qualification. So we followed a procedure where we've identified numerous vendors in for each components, and then we set up an internal committee between engineering, supply chain management, manufacturing, and R&D, and who sort of shortlisted the vendors, held discussions with them, and then qualified those respective components for the individual vendors, and accordingly sort of signed them off, which according to me is a very, very important step, because we spent a lot of time between vendor development and vendor qualification. I think we have spent more than 1.5 years, and which is really required when you want to do a proper diligent process. Then, naturally, once we've qualified the vendors, we are looking at standardizing the various models within the electrolyzer systems. So, say if we have a module of a 2 megawatt or a 4 megawatt or a 8 megawatt module, we are trying to standardize the philosophy of the vendor development and qualification within these modules. The next points are strategic sourcing, which basically means that we are also engaging with various tier 2 and tier 3 suppliers to align with the sort of requirements which are coming up as far as the electrolyzer sourcing is concerned. And as L&T, we typically work on a long-term strategic relationship, which we have mentioned here. And this is basically in terms of partnership and not exactly a relationship for a project or a transactional relationship. And the last element we have said is, which we feel is very important, because is R&D and innovation. Because I think, again, I come back to this area of electrochemistry. It's very important that as far as electrolyzer landscape is concerned, we are continuously innovating on materials. We are innovating on product development and product design, which ultimately will result in better efficiencies and better specific energy consumption, which comes out from the electrolyzer, which again becomes an important part of the cost of green hydrogen. I'll move to the next slide. So this aspect I would like to cover is on reliability through indigenization. So I mean, here I will take, your box number 1 and the box number 4 together. So if you ultimately are able to reduce the import dependency, then actually what you're doing is you are reducing the chances of disruptions from, global sourcing and geopolitical dependencies, which I think is very important. And also this aspect is related to the after sales support, because if ultimately you have a product, like we have a factory here in India, we offer at the moment an extremely strong domestic service network, which naturally will ensure a much faster turnaround. And you have the experts stationed here, which can reach the site in case of any requirement for maintenance or troubleshooting in the shortest possible time intervals. The second and third buckets which we have mentioned revolve around risk mitigation. So, as a part of risk mitigation, if we have the factory in India under the Make in India program, we and the ecosystem with majority of our sourcing that we are doing or outsourcing which we are doing within India, then naturally it gives you a much greater control as far as the timelines is concerned and as far as the overall commercial numbers are also concerned. If you talk with reference to cost optimization, also by indigenizing the electrolyzer system, we are able to have a much better control on the life cycle costs via local servicing and faster spare availability. So, some points which I would like to mention here is basically as far as indigenous electrolyzer manufacturing is concerned, I think we are putting a lot of focus on items which are not manufactured in India. So, which typically, is the membrane. Uh, we are importing it from one of the big companies or one of the leading companies, I would say, in the world in Europe, Belgium. Uh, this is one of the major components, I think. So when we say that we have to indigenize, so you have to sort of either a company in India who are typically into, say, polymers can come into this. Either they can talk to these players who are global majors as far as membranes are concerned, and accordingly, the government should be able to provide support to such companies to set up a facility here. The other points which we have mentioned here uh, is supporting research to reduce loading on critical components. Again, like we have a R&D set up within our company, where we are focusing on indigenization of the imported components. It's important that we have discussed this with the ministry also, that they critically should look into uh, tying up with institutes and giving them specific programs or specific projects, individual projects to various institutes and different projects to different institutes, wherein this aspect comes out, so that there will be a definite KRA which comes about with the various institutes. The third is developing a resilient supply chain network. So here I would like to say is, I would like to also give the example of China, that typically if you have electrolyzer production capacity of, I would say, 7 to 8 gigawatts in that country, what they actually do is the backward integration in terms of the supply chain network is to that equal capacity. So which actually means that you also need uh, ecosystem of vendors who are able to cater to that capacity. Now, in India, we have 12 or 13 players who have come as a part of electrolyzer PLI. But if you actually look at the vendor base in the country, I think there needs to be a lot of focus which needs to be given on developing vendors for the respective technologies. Otherwise, what we will find is we will have electrolyzer OEMs, but the vendor base is not there which can provide material for the electrolyzer systems. The fourth point and the fifth point are related. Very important to have a testing infrastructure uh, as a part of the electrolyzer OEM setup, so that the stacks can be tested as well as the modules, depending upon the case or the capacities which is there. Uh, the infrastructure needs to be there in place. Otherwise, the reliability will cannot be ascertained. And naturally, the fourth point which is mentioned is we need to have unified standards for performance testing, because ultimately we need to harmonize with global standards. So when we say unified standards, what we mean is actually uh, to have standard protocols for testing. So if I take out a stack, then it should be defined that we have to test it at this load for so many hours, and accordingly, the parameters which we have to assess from that testing are, for example, the specific energy consumption, the hydrogen production, or the hydrogen purity, whatsoever. But these parameters also need to be defined as a measure of the protocol which is there. So this was my last slide. Uh, Thank you very much once again for the opportunity which was given. In case there are any questions, I would love to take it.
Yeah. Uh, Thank you very much. So while we're waiting for questions to come, Siddharthji, I have a quick question from my side.
Yeah,
So you have done, sorry, yeah, you have gone from the conceptualization to actually rolling out your first prototype in 2 years, so which is a major achievement, 2023 to 25, yeah. And also have achieved 85% indigenization. So kudos to your team for achieving all of that. The second question was primarily what kind of cost reduction was achieved compared to the first imported versions of electrolyzer that you probably have engineered and indigenized. Would you be able to throw some light on what kind of cost reduction and delivery timeline reductions were achieved?
uh, yeah. So definitely, Srinivas, that's a very pertinent question. Though I would not like to mention specific figures, but just to give you an idea, say if the first electrolyzer uh, assembly I do it based imported from Europe, with the major parts coming from Europe, I've achieved a 50% reduction typically when I've done this in India. Just to give you an idea, that which is quite substantial, and I think as per the targets which we had internally.
Okay.
In terms of the timelines, uh, see, I think I would like to mention we have recently a job with us, which is for Indian Oil Panipat, right? And
Correct.
as electrolyzer supplies, L&T has received the development order for IOCL. But as far as electrolyzer is concerned, we are going to, deliver the electrolyzers in the next, I would say, 14 to 15 months, 15 months.
Okay. Okay.
So 100 megawatt is, and that's a quite a decent size. And we would be doing it in the deliveries in 14 to 15 months of the
Okay.
complete modules. Six
Okay.
modules of 16 megawatts. Yeah.
Okay. Okay. Great. 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 Um, Yeah, I don't know if there are any other questions, but I would just like to take one more question. Yeah, you to take one more question. You did indicate a few components such as membranes, which need to be indigenized, right? But are there any other areas where you see some weakness in vendors that could be of focus apart from component which is a membrane, any other area where you saw a weakness in the vendors which needs to be covered up?
Uh, well, see, typically, if you see, I would say the area where I think we really need to work on is the availability of the critical materials. So, I mean, if I remain limited to my alkaline design, pressurized alkaline design, which we have,
Sir.
then in that case, I would say nickel is one of those materials which is not available in the country, but has to be imported. And naturally, that is where the vulnerability of the supply chain also comes into account. But we have sort of developed vendors where the adequate risk protection has been done or has been taken care of. But these are the areas where I feel, uh, from a material perspective, is what one has to take care. Uh, Besides that, I mean, from an Indian context, you have MSMEs and you have a number of MSMEs.
Sure.
But I think there is a lot of hand holding which needs to be done, because ultimately, if you have to achieve the quality levels, if you have to achieve the scalability levels, and if you have to achieve the cost levels which is desired from this space, then it is very important that we sort of handhold the vendors, and we give them suitable incentives and benefits in which they can see the larger picture, so that they can move at a very fast pace. Because as you can see, typically, in sourcing, and if you compare where we stand vis-a-vis where China stands, uh, then you know I mean, probably they have electrolyzer production capacity uh, which is somewhere around close to, I would say, somewhere uh, 18 to 20 gigawatts today. And they have a backward integration which is similar to that extent. So that means there is a vendor base in the country. And it's very
Okay.
interesting, if you see, you have majority of the players, electrolyzer OEMs, are only into alkaline technology there. So the country has developed the whole ecosystem for one technology, knowing very well that, say, for some years this is going to play a major part, and the whole ecosystem has been developed around that technology.
Okay. Okay. Yeah.
Right.
Yes, sir. Yes, sir. Thank you. Thanks for kind of candidly answering both the questions. And
Thank you very
So
much, Mr. Srinivas, for giving me the opportunity.
yeah, maybe one last question.
I
Yes.
have I have one question, Mr. Siddharth. I'm
Yeah,
Sridhar
yeah.
here. Good
Right.
evening. Thanks for your nice introduction and presentation covering the entire gamut of the electrolyzer manufacturing to the risk mitigation challenges and the supplier base coverage. I just had a general question where we can discuss further also how how we are mitigating the precious metals availability for the electrolyzer stack production. Today there are a lot of what do you call pedals which have been put by the government both in India and overseas, where they need some specific license, for example, like iridium or titanium, for example, to get into India for making the electrolyzers. How is L&T overcoming these challenges, sir?
So, Sridhar, actually, that was one of the reasons we went into the alkaline technology, where
Okay,
where that sort of the PGM metals are not there. That's what
right.
I just mentioned in my earlier point. It's only nickel, which is one of the materials
Right.
which is not available. Otherwise, we don't have any sort of precious metal as a part of our ecosystem.
Understood. Thank you. Thank you, sir.
Yeah.
Thank you very much,
Thank you.
Siddharth sir, for again willingly agreeing to share on a sensitive topic like indigenization, and also answering all the questions so far. Thank you very much.
Thank you so
Um,
much, Srinivas, for giving me the opportunity. It's really a pleasure for me to be here.
yeah,
Okay.
yeah. Thank you. We now move on to the third. Yeah, I think there was one other question on the chat. Uh, Nickel ore is also required, was the question. Siddharth sir, if you may answer. Siddharth sir?
क्या क्वेश्चन है यार?
Yeah,
What
there's
is the
one
question?
question. Is nickel ore is also required? In the sense, I
Yeah,
think only metal or ore was, I think. Question.
yeah.
But the
So,
nickel is 100% nickel.
so this is typically, what we require is, it's a very specific question to the design. So we require sort of nickel wires, for our electrodes. So, I mean, if the question is related to a typical sort of party who's into that, they can connect with us, because it's more of a design related thing. I wouldn't like to just
Sure.
mention more than that,
Yeah.
and we can always chat over offline. He can connect with me if they
Sure.
have a sort of, if they are into this, or they have a supply chain related to me.
Okay. Thank you. Thank you very much, sir. Yeah.
Thank you. Bye bye.
Thank you. So now we move on to the next topic, wherein we're going to be talking about advanced materials, novel stainless steel grades, and how they help in addressing the reliability, durability of balance of plant, and even the core components of green hydrogen production. Over to you, Varun sir.
Thank you, Srinivas. First of all, I would like to thank Rich for giving us this opportunity. And Karan and Siddharth have rightly raised two important topics, so I would like to take that forward with my presentation. Let me know when my screen is visible.
Yeah.
Is my
Yes.
screen visible?
Yes, we can see the Canva. Yes. Okay.
Okay. So we are a part of, just give me a minute. Yeah, now my screen is visible, I believe. So
Yes.
who we are? We are a part of Jindal Stainless, is a part of OP Jindal Group. Just give me a second. Yeah, so we are a part of OP Jindal Group, which was founded in 1970. This group is comprising of primarily four major companies: Jindal Saw, which is primarily into pipes; JSW, which is primarily into most of the carbon steel and other diversified areas. I am representing Jindal Stainless, which is totally into stainless and mining industry, and JSPL, which is primarily one of the carbon steel and power producers. Now, our journey started with long back, and we are at a capacity of right now 3 million tons. And we are overall contributing to net zero emissions and trying to achieve by various efforts by indigenizing a lot of things in India. Now, to set the context, we ourselves are one of the off-takers by setting up first of its kind a complete alkaline electrolyzer supplied by Hygenco on BOO model, which is indirectly replacing our ammonia requirement by hydrogen. We've also put up one of the rooftop floating solar plant. This is in Hisar, so as to contribute to the overall national green hydrogen mission. As Karan has rightly indicated, we are also doing it at our new plant, which is coming up in Jajpur. So this is again the same technology as Siddharji has rightly pointed out, this alkaline electrolyzer, which is now talk of the town, and most of the players are already getting into this technology, and almost like 80-85% of the electrolyzer are getting indigenized here. So we are putting up another electrolyzer setup of 600 nm cube, almost about 3 megawatt units that is going to come up. And there are also another things in pipeline of almost about 900 nm cube, which we are using as a source of hydrogen in our bright and bell annealing furnaces, reducing ammonia and replacing it with hydrogen. Now, as everybody is talking about National Green Hydrogen Mission, and it was said that manufacturing, R&D, and development, these are the three key parameters. But today still we are talking about the materials. Are we material ready? Yes, we are somewhat material ready, but there are still certain rare earth metals which we are still vouching upon importing from outside, specifically items like nickel, which are an input for our stainless steel manufacturing also. So there are certain things which we are trying to overcome with stainless steel by selecting the right materials for right applications and overcoming the overall cost of manufacturing and lowering the complete life cycle. Now, the very important topic when we talk about hydrogen is hydrogen embrittlement. Now, this is a molecule what we are talking about, which normally creates and plays very crucially, and it leads to a problem called hydrogen embrittlement, which definitely can diffuse into the microstructure, the metal lattice, and can initiate a catastrophic failure also. So selection of right material is very important, and that can definitely help you out in overall overcoming all the small nitty-gritties of electrolyzer, balance of plant, and all associated industries linked with the complete value chain. Now, if we look at the hydrogen value chain, it starts right from the input, the green input. Now, we are already providing a lot of solutions for solar, wind, pump, storage, and we have indigenized these solutions by providing different solution for different applications. Like for solar, we are already providing lean duplex solution for solar panel mounting structures. Offshore wind is another renewable area which is now coming up in a big way, and we are already material ready with our duplex solutions, where it provides high strength, corrosion resistance, and superior chloride resistance against the material. Another big area which is coming up parallelly along with thermal and other areas is pump storage and hydromechanical, where we are already catering for different hydromechanical structures like radial gates, spillway liners, and specific duplex material. Now, if I talk about the other part of this value chain is production. What Siddharji is talked about electrolyzer with alkaline technology. We have already indigenized few along with technical institutes as a part of our development initiative and R&D initiative. We have already indigenized and come up with a lot of solutions for high pressure, low pressure, high temperature and low temperature applications like 304 with high nickel, 316, 441 and 446 are different grades which are used in solid oxide and fuel cell technologies. If we talk about, yes, this is another thing which we are already working with Bureau of Indian Standard. This is the standard which is getting formalized, which also already talked about the hydrogen embrittlement, corrosion and wear resistance, impact strength, temperature effects, and erosion. So we are already getting into this so as to get the right material for right application when we talk about hydrogen electrolyzers. Now, there are certain challenges which most of the, I believe, these developers or down the line, the EPC manufacturers must be facing. The prime thing which I talked about is embrittlement, but definitely when we're talking about alkaline environment, there is an accelerated corrosion due to this KOH solution in which this complete process is happening. And it leads to the leaching of these bipolar plates, metal, which is acting as a cathode and anode. As a solution, everybody is looking for nickel plating, maybe electroless plating, electrolyte plating. But again, there is a shortage of nickel. And parallelly, other industries are coming up like EVs, where this nickel is getting consumed in a big way. And if you look at the total value chain across globe, there's hardly any nickel on earth, hardly 3.5, and most of the nickel is consumed by these stainless steel manufacturing companies. So this is one of the area, and definitely this nickel plating, if it is not done properly and it is not indigenized, though automobile industry is well developed in India, but definitely there are certain things where we are dealing with this hydrogen, and this is a very notorious molecule. So if by any chance anything peel off, chip off these coatings over any other material, it definitely there is a compromise on the overall system, and it leads to that failure of this complete system. Then there are other different types of corrosions which are coming up, dealing with different carbon steel or maybe any other material going into different technologies, which is still under development stages. So we are ready with our solution for the industry, where we can add value by giving the right solution, understanding the environment with whatever technology is coming up. The next challenge which is coming, which is right now not very prominent, but it will come because of the efficiency issues of these electrolyzers. And lot of machining is happening in the internal components of an electrolyzer. So there are ready-made solution. We being an OEM as a mill, so we make these ready material with required flatness, tolerances, which definitely will overall increase the efficiency of these electrolyzers. Again, this service life, since as an EPC or as a developer, everybody looks for promises with these specific hydrogen electrolyzers, where different technologies are getting used like alkaline, PEM, SOEC, where a bare minimum commitment is required in number of hours if it is run continuously. Another aspect where this technology, where PEM is not picking up, though it's a better technology, or solid oxide, because a lot of rare earth metals or specific exotic materials like platinum, iridium, titanium, they drive up the total overall stack cost. So definitely it will, everybody has to look at these aspects while manufacturing these electrolyzers and indigenizing all these technologies. Now, if we talk about specific electrolyzer, we have developed bipolar plates for alkaline, PEM, SOEC, or AEM, even for fuel cells also. And there are specific recommended grades which we have internally and externally tested in authorized NABL approved labs. Rather, we are setting up our own internal R&D lab with all these testing facilities which are required to test these materials, specifically for high temperature or at ambient condition, and also at cryogenic conditions. This is one of the first of its case, which was developed with Jindal Stainless material. SS304 was used with BPCL designed by BAC, and it was well proven for bipolar plates in this alkaline technology. Though this design is a little bit bulky, so now people are shifting to the lighter weight of electrolyzers with higher efficiencies. So we are also modifying the whole ecosystem. We are also adapting to the whole ecosystem and developing new materials also. That's why we come up with a better grade in 304 itself, which can be used with higher nickel content, which can be overcoming all those leaching problems, impact toughness, and all those. Now, if I talk about another part of this value chain is storage and distribution. So we are ready with, and we are already doing this and exporting a lot of material in different application in balance of plant, transportation vessels, specific grades like 201 LN, 317L. These are the specific grades which we are using for different equipments in the whole value chain or in the whole ecosystem of this. This is one of the case which we have done for Inox Kandla, and we have used specifically 316L. This was a cryogenic tank which was given to Inox and exported to Korea for their one of their project. Another one of an classic case where this grade was developed and indigenized in India for specifically cryogenic liquids like LNG, hydrogen stored at higher pressures. So this is something which we are developing and indigenizing along with the complete value chain and delivering it to companies in India and exporting. This is again one of the global benchmark case, which is first liquid hydrogen carrier. And again, similar austenitic stainless steel application, austenite stainless steel application was there. And one of this family was used to take care of this liquid hydrogen material. These are few of the materials and case studies which we have indigenized and developed for handling liquid ammonia in transportation sector, for reactor vessels in 316, 304 to overall take care of cryogenic temperatures and high corrosion resistance at extreme temperatures. Now, this is also one of the upcoming area where we are talking about a lot of projects which are coming in ammonia as because urea is coming as an upcoming sector, biofuels and SAF, which is talk of the town today. So we are already developing and making these materials in India and supplying for different projects like we have done it for this bioethanol and methanol in duplex family of stainless steel. 80% of the ethanol producers in India are sourcing stainless steel from Jindal Stainless for their complete process plant, including fermentation, distillation, handling, and water treatment processes. This is new area which is becoming a promising post discussions with various stakeholders in the sector. So we are already ready and we are already in the development phase where we are working up with a lot of materials and grades which we can supply for this specifically biodiesel and biorefinery industries.
Varun,
Some
time check.
to sum it up, this is my last one. So to sum it up, so with stainless steel, we are trying to take care of first and foremost problem, which is hydrogen embrittlement, corrosion resistance, then better life cycle, and this is a material which is well only skill set is the point which we are trying through a different initiative by creating a complete setup where stainless academy is being set up to educate and create that skill set for the industry. And this material is well stable with good electrical and thermal conductivity. So we are here as a solution provider from material perspective. That's all from my side. If there is any question, then welcome to address those problems. Over to you.
Yeah.
Yes.
Thank you, Varun. Yeah, the floor is open for any questions from the audience. I have a quick question while we're waiting for some more questions from audience. Just to understand, you might have worked on, say, the portion, or say, if you look at the total balance of plant costs and material costs, right? What portion of the material cost would be stainless steel? Have you done any analysis of that nature? Just to understand. So if you look at a 1 megawatt electrolyzer, what portion of the material cost is stainless steel?
Okay. So to answer your question, so typically if I talk about a specific technology, alkaline technology, let's say, so typically it consists of approximately 10 metric tons of stainless steel, and balance of plant will be somewhere around 1 metric ton, including all piping, buffer tanks, and all storage tanks which are in the part of ecosystem. So if we talk about more about the costing part of it, it is more about the life of the whole. So if in terms of life cycle costing, definitely none of the electrolyzer has served or has entered into that complete service life, because all these electrolyzer to run for 60,000 hours annually, it has to be somewhere around 6 years or 10 years life has to be given. And we are very much sure with material like 304 with high nickel and 316, definitely these hours which are promised by these fabricators and EPC manufacturers can be dealt with minimum maintenance cost.
Okay, okay. Thank you, thank you. What are the alternatives beyond stainless steel, maybe that you have in your horizon?
So we primarily our focus is on stainless steel, but we are also developing a lot of alloy steels where we are trying to cater other different segments. And we are also into, so this is primarily using the flat products, which we call sheets, coils, plates. So we are also doing a lot of development in terms of alloy steel for thermal power plants, utilizing high-end for high temperature AUSC technology for thermal power plants. We are also doing hot roll bonding cladding of materials. That is something called bimetallic plates used for specific pharma industry, chemical industry, and thermal power FGDs and non-FGD applications. Apart from that, we are also into long products, which we say wire rods, forged bars, and TMTs, which is primarily going into structures, bridges, foot over bridges. So all these areas we are addressing with different combinations. But our prime focus is to increase the portfolio of stainless steel
Okay,
majority of.
okay, okay. Yeah. Any questions
Yeah,
from
hi.
audience?
I have a question.
Yeah, Chintan.
Please.
Hi, this is Achintya from Highland Power One. So this question is specifically towards material development required for solid oxide systems. You did mention
Yes.
that you have developed specific interconnect material for solid oxides. To what extent has this material been developed? To what extent has this been tested? So we are into the development of solid oxide electrolyzers and fuel cells, and are currently looking for materials for interconnects, but unfortunately we've not come across any in the Indian vendor through the Indian vendors. So I was quite curious to know how Jindal is working towards this, not only for interconnect, but also like you mentioned, for a lot of other BOP components, especially for the high temperature section in and around 800 degrees.
Yeah, very valid question, Achantil. So we are already in development of specific material with high percentage of chromium and nickel to specifically cater this high temperature conditions. Since it is still in a very nascent stage where we are developing this material, but typically in a solid oxide application, our grades like 441, 445, all these grades are typically used for this where high temperatures come into play, and this is off the shelf product. The quantum is less, but we are also working simultaneously with few players outside country where we are developing this as a regular solution for SOEC technology and fuel cells.
Okay, thank you.
Right.
Thank you.
Thank you, Srinivas.
Yeah, thank you, Varun, for your wonderful presentation. Now we move on to Himadri for his talk on, the most important thing, how do we reduce the cost of hydrogen to under 300 rupees a kg? Himadri, over to you.
Right. Am I audible?
Yes, you are. So let me
Yeah.
stop sharing so you can share your screen.
Sure.
Yeah.
Thanks for giving the opportunity. Well, I'm sharing my screen. So it's most one of the pertinent topic uh, in today's world, right? So we have already seen significant amount of price reductions both in hydrogen and ammonia, right? So and that is kind of a benchmark that we have seen, right? If we have seen the uh, around the globe, what is the kind of price discovered both in hydrogen and ammonia, that's almost doubled what we have discovered here, right? So, for example, the recent ammonia options we have discovered it's less than $600 per ton of ammonia. But if we see the similar kind of auctions that have happened globally, that's in the range of 1,000 to $1,100 per ton. So, and we are now talking to reduce it further, right? So just to set the context is that I mean the increasing acceptance of hydrogen in the overall energy system is basically underpinned by three long-term trends. So one is obviously the declining cost of renewables. We have seen the cost of renewable in the range of 2.5 to 3. Obviously, this is plain vanilla solar and wind. It's not the RTC cost, but that itself shows that the overall cost of renewable is declining. The second trend is that there is an increasing focus towards industrial decarbonization. So most of these countries are taking pledges, as well as the corporates are taking pledges towards carbon neutrality. Many of these large players, they have already announced their net zero pledges. So they have to somehow decarbonize their energy mix. And not all the industries that can be decarbonized with electricity only, renewable electricity only, but there are hard to abate sectors where you need other form of decarbonization. That's why hydrogen is playing an important role. And third part is that there is an increasing focus towards energy security, right? So we are very much dependent on import for crude oil and natural gas, but hydrogen, if we can produce domestically, because we have significant amount of renewable resources, so that can at least compensate some amount of imports, which would eventually contribute towards the energy security of the country. Now, while we talk all of this, but the essence of anything is basically the economics, right? It has to be uh, competitive vis-a-vis the other fuel, and that's where the discussion is that how we can reduce the cost of hydrogen production. So we have already seen that it's around 330 rupees per kg we have discovered in the refinery bits recently, and now we are talking that how we can reduce it to less than 300, right? Now, when you say that less than 300 rupees per kg of hydrogen, what does that mean, right? So what exactly the cost tax looks like in case of hydrogen productions, right? This is only the cost of productions. This is not any other cost like transportation, storage, and all. Actual landed cost could be a little higher based on the type of transportation and logistics you are you have that kind of means. This is only the cost of productions. So let's say if we go backwards, right? So let's say I have a target of 300 rupees per kg of hydrogen cost of productions, and we have some idea about the capex and opex, right? So 50 to 55 rupees per kg, that would be the proportionate of the capex that would contribute to the per kg of hydrogen cost. OPEX is around 25 to 30. And within CAPEX, it includes the electrolyzer CAPEX, your hydrogen storage CAPEX, infrastructure CAPEX. Then it will also depend on your stack degradation, right? Because you will also have to incur future CAPEX. Then also there will be some impact on the government subsidy and obviously finally the financing cost, right? So that contributes around 50 to 55 rupees per kg. But again, that's not a sacrosanct kind of number because it varies significantly depending on that what is the kind of oversizing of your system, what is your electrolyzer capacity and all, right? Then comes your OPEX. So OPEX mainly is your O&M cost and your SG&A cost, water cost, insurance cost, and various other miscellaneous cost. Now, if we deduct these two from 300 rupees per kg, right? So it comes around 215 to 225 rupees, which is the cost of electricity that that would contribute to your 300 rupees per kg of cost of hydrogen production. So which is approximately around 70% of your cost of hydrogen production. Now, 1 kg of hydrogen typically takes around 54 to 55 unit of electricity depending on the efficiency of the electrolyzer. And that translates that your landed cost of electricity has to be within the range of 3.9 to 4 rupees per kilowatt hour. Now, while it looks achievable, but what I'm saying is the landed cost, right? So landed cost also adds your additional transmission and distribution cost. And let's say if you are not putting up a captive plant, if you are taking the electricity from some third party, so you also have to add the open access charges, which is the cross subsidy surcharges and additional surcharges. So those are significant. In some of the states that can go up to 2 rupees per kilowatt hour. So this is something, I mean, if you can achieve of this kind of landed cost of electricity, 300 is achievable, simply put like this. Now, I mean, what are the factors that is contributing to the electricity cost? Obviously, what kind of renewable energy mix you are taking, right? So how much solar you are taking, how much wind you are taking, how much BESS you are taking, right? Because let's say if you're going solar heavy, right? So in that case, probably you need to add some BESS. But let's say if you go wind heavy, your capex will be on a higher side. So that will have a kind of trade-off, right? That what kind of RE mix you are taking, and that will depend on what kind of sites available with you, right? So for example, if you have a sites available in Rajasthan, probably will go heavy on solar. But let's say if you don't have a site in Rajasthan, you have a site in the southern part of the country where the solar irradiation is not so great, probably will go wind heavy. Obviously, that requires a kind of optimization, so which kind of configurations depending on your profile that would lead to your most optimum landed cost of electricity. Then also, what is your renewable energy capex? What is the O&M cost? What kind of degradation you were considering? And as I said already, that what kind of T&D charges and whether banking is not available or not, right? So these all will impact your cost of electricity. Now, if we just deep dive a little bit on some of the key cost reduction levers, right? So as I said that in the recent refinery bids, we have already seen that 330 is achievable, right? Now, if we have to go below 300, we need some incremental incentives and resource optimization that could bring down the cost to around 300. Now, what are some of the levers, right? So two major levers, as I said, right? So one is definitely the capex, and second is your electricity cost. Now, here when I'm saying capex, it's the capex of both, basically, your electrolyzer and renewable energy both. Now, we have some subsidies under the National Green Hydrogen Mission, right? So green hydrogen has a PLI, electrolyzer also has a PLI, both will contribute to the cost reduction. Then there are states which have some specific capital subsidy, so which differ state-wise. So for example, some of the states have a very generous kind of incentives available, which can go up to 30% of your total plant and machinery's cost. So that's a significant amount of subsidy which can reduce your overall capex contribution towards the cost of production. Then another lever is that electrolyzer cost reduction through rapid indigenizations and engineering innovations. So already Siddharth has spoken about that as we go more and more for indigenizations and the economies of scale is achieved, that would also lead to additional capex reduction. Now, who are the major responsible player, right? So for any kind of subsidies, it's a state and central governments, they are responsible for subsidies, disbursing any kind of subsidies. And then there are the OEMs like L&T and all, right? So how fast they are indigenizing, how fast they are scaling up their operations and what kind of innovations they're bringing, right? For example, what kind of material is being used, what kind of efficiency improvement is expected going forward. So that would all lead to your overall capital cost reduction. Second, which is a very important aspect and where the developers would play an important role, is that how you're doing your sizing, right? So it has to be optimized. That, I mean, as I said, right, that how much solar you will be putting, how much wind you will be putting, how much BESS you will be putting, how much electrolyzer capacity you will be putting, how much would be your hydrogen storage. That would come from an optimization kind of model. I will illustrate that in one of my next slides. Because let's say if you go heavy on solar, right? So then you have to generate most of your hydrogen in your solar hours. So your electrolyzer have to be oversized. And at the same time, you have to store that hydrogen. So your storage size will go up. But at the same time, your RE capex will come down. So there is a balance between these two, right? That how much RE you are putting up and how much electrolyzer you are putting up, and what is the impact on overall cost of electricity and cost of hydrogen, right? So that kind of optimization needs to be done by the developer. So that's one of the most important levers for your overall reduction of cost. Then electricity cost reduction. So apart from RE capex, right? So there are other charges, right? So those are available which are related to the T&D charges. So it's basically speaking about the T&D charges. So the interstate charges which are already waived off till 2030, it may or may not be extended, but till now at least it's waived off. But there is also state transmission utility charges, STU charges. There are partial exemptions in some of the states. In some of the states, it's not there. So probably that's one important lever, that how much, how much waiver you are giving towards the reductions of state transmission charges. Then how we are sourcing the electricity, right? So you have an electrolyzer plant. Now, if you are putting up a captive RE plant, as per the definitions of the CA and CRC, so in that case, you will not be charged any kind of open access charges like cross subsidies surcharge or additional surcharge. But let's say if you are buying that power from some third party, let's say some REIPP, he is putting up plant and he is selling it to you. So in that case, in addition to the cost of generation, in addition to the cost of transmission, there will be additional charge towards open access charges, which is cross subsidy surcharges and additional surcharges. So as I said, that those are significant amount, right? So your landed cost of electricity will depend also on how you are sourcing your RE. If it's through captive route, it will be lower. If it is through third party open access, it will be on a higher side. Then third point on electricity cost is that whether there is a provision of banking, right? Because we are talking about renewable electricity, so there will be a lot of variability. If there is a provision of banking, so the wastage would be limited. There will be less amount of excess power. The excess power can be banked at the grid, and then it can be taken off when the RE is not available or the RE is low, right? Especially it happens in some of the months where the RE resources are on a very lower side. So those months are basically will be the most benefited from banking. Now, whether there are policies in each of the states, but the actual implementation of banking is very limited because it has an adverse impact on overall grid stability. So that is one important aspect. As our grid matures further, probably the banking would be a reality. Now, again, the responsible parties are state and state regulatory commissions, which is the approving authority for any kind of exemptions or any kind of banking, and also the transmission utilities. And the developers would be responsible that how we are configuring the projects. Now, third point is that engineering innovation of electrolyzer, right? So I mean, what kind of efficiency you have in your electrolyzer stack, what kind of stack degradation is happening. So if you have a lower degradation of stack, then your overall capex would be in a lower side. Otherwise, in every 8th year or 9th year, you have to change your almost the entire stack, and that would a significant cost. So based on your engineering innovations also, that would also lead to a reduction in the cost. And some of the other policy level initiatives are also there. So for example, we have a concept of SEZ, right? So if you're putting up SEZ, some of the materials, some of the some of the components which are not available in India, or let's say till the time our domestic industry is matured, probably low cost import can be allowed. So that would eventually lead to your reduction in the capex, right? Obviously, that would have an adverse impact on the local industry, but that's why I said that till the domestic industry is matured, probably there could be a provisions. Obviously, that's an option. Whether it would happen or not it is a different thing, but probably promoting a zero rated low cost import could also reduce your overall capex. Now, these are the key levers, right? So I will just deep dive a little bit on the optimization part, because the rest of the things are very, very straightforward, right? So if I'm given subsidy, I will have a cost reductions. But apart from subsidies and incentives, the lowest cost of hydrogen or derivative productions will require a overall system level optimization, right? So in this picture, right? So what I'm showing is that I've also shown a kind of integration of ammonia, which is a derivative, right? Because the integration of ammonia will make the system further complex, and the optimizations would be more crucial. Now, this is the electrolyzer, right? Now, the electrolyzer is powered through wind and solar, and we have also indicated a kind of base if it is required. And the power can come directly from the wind and solar, or it can come through base. And also you can have an option to take it from grid, because our hydrogen certifications allows that 2 kg of CO2 per kg of hydrogen. So around 3 to 4% power still can be taken from grid, considering our grid emission intensity is around 0.8 kg per kilowatt hour, right? Now, if it is an integrated plant with ammonia, right? So then hydrogen can directly go to ammonia, or it can directly it can go to the storage, and from storage it will go to the ammonia, right? Now, what is more important is that you have to optimize the entire system, right? How much RE capacity has to be installed, because RE has different kind of profile in different month, right? Especially when you have wind. October, November, December is a very low wind. So those are the time how we will be managing your electricity requirement, right? Whether you need to size the electrolyzer higher, or whether you need to size the solar on a higher side, how much would be your hydrogen storage, what would be the sizing of the base, how much you can purchase from the grid. So a system level modeling is very, very critical, due to the variable RE generations, and also you have module degradations. Every year your solar output will reduce, every year your base output will reduce, every year your electrolyzer output there will be degradations, you will require additional electricity. So when you model all this for the next 15 years, right, you need to have a kind of solid sizing modeling that would give you the most optimum capacity of solar and wind, right? And that would eventually lead to your overall capex optimization. So I'll just give a kind of illustration, right? So we extensively use it in Deloitte in many of our assignments, right? So where basically you have to give inputs on hydrogen or ammonia demand, you have to give inputs on capex, opex, electrolyzer efficiency, degradations, electrolyzer flexibility, right? So whether you can frequently ramp it or ramp up, whether you can frequently ramp up, ramp down your ammonia plant, what is the cost of your hydrogen compression, what is the requirement of compression, then also the RE specific inputs, right? So solar and wind profile, where you are putting up the plants, right? So if you are putting up the plants in Rajasthan, your profile would be different from if you are putting up the plant in southern region. What is the degradation, right? What is the T&D charges, banking charges, and inputs on the energy storage, battery storage, what kind of capex. So with all these inputs, basically, you need to optimize that. What should be your renewable and storage sizing? What would be your electrolyzer sizing? What would be your storage sizing? Hydrogen storage sizing, and finally the most optimum cost of electricity and hydrogen, right? Now, from a developer's perspective, right? So what are some of the key imperatives that where to put the RE? So once you do the optimization, basically that would help the developer in overall making some decisions about the plant, and eventually reduce the cost, right? That where should we put the renewable plant, right? Where and what will be the mix of RE? What would be the impact of flexibility on the electrolyzer performance, right? Let's say if it's solar, right? You have to frequently stop and start every day. So what would be the impact of that frequent start stop in your electrolyzer performance, right? So these are some of the key imperatives for the developers, and probably this is one of the most important levers that at least we have understood, right? That can lead to your significant amount of cost reductions. If your overall sizing is not optimal, probably your cost will be on a higher side. On top of that,
Quick time
yeah,
check.
yeah, this is the last slide. On top of that, there will be some other area kind of which are mainly related to policy and regulations, right? Uh, there could be, at least for the initial years, right? Next 2, 3 years or 5 years till the industry is mature and the other cost component comes down. There could be an exemptions in the transmission utility charges. So, for example, state to state, it varies. It varies from 0.4 rupees to 0.8 rupees, right? So, if we can completely waive it, right? So that would reduce my cost of hydrogen by 20 to 40 rupees per kg. Similarly, banking of electricity, if we allow it to some extent 10 to 15%, right? That will also have an impact of 5 to 8 rupees per kg. Then waiver of open access charges. Let's say if you're not putting up the plant in captive mode, if you're and you're putting up the plant in third party route, right? So that open access charges could be waived off because that is significant. In some of the states, it can go as high as 2.5 to 3 rupees per kilowatt hour. So that will make the production of hydrogen commercially unviable. So these are some of the key levers, right? I'm not getting into the exact figures because that will vary from state to state where you are putting up the RE, what is the size of electrolyzer. So all this will depend on that. But prima facie, these are some of the key levers which should be looked at whenever some developers putting up their plant, or some of the points for the policymakers and the regulators to look at to reduce the cost of hydrogen. Yeah, so I will take a pause here. If there is any questions, would be happy to take up.
Yeah, thank you, Himadri, for the quick presentation. I think there are a couple of questions on the chat. The first question is from Karthik Bhatt saying, with these assumptions, what must be the cost of electrolyzer in terms of dollar per kilowatt? I think that was, yeah, addressing your third.
Right. So dollar per kilowatt. So it's still evolving, right? If you take the quotation from the Chinese vendors, it can go as low as $250 per kilowatt, right? But if you go for some Western vendors, for an alkaline electrolyzer, it can go up to 500 to 550 also, right? So I mean, this 50 to 55 is considering that overall system level capex at around 4.5 crore per megawatt, right? So which eventually translates the cost of electrolyzer of approximately $450 per kilowatt, because the rest of the cost is towards infrastructure and the financing cost. Around 4 to 450 could be something realistic as of today.
Okay. The second question is from Vaibhav Vinod. How opting for hydrogen storage could decrease the capex cost of RE? I feel only the cost of BESS could be optimized by hydrogen.
No. So yeah, so the thing is that basically you are reducing your wind, right? So wind is very costly, 7.5 to 8 crore per megawatt. So hydrogen storage, when you are increasing the hydrogen storage, right? So basically you are using your electrolyzer in the solar hour. So you are generating more hydrogen by oversizing your electrolyzer in the solar hour and storing it in the storage, right? So basically you are you have to see that at what point it would be optimum, because it also cannot be go infinite, right? So you are avoiding wind for operating the electrolyzer and storing it during the solar hour.
Okay. Yeah. There's I think one other question from Chetan. What can be the cost of hydrogen production via biomass route?
Yeah, so biomass route is something tricky, right? So supply chain is the issue, main issue. At what cost basically you are getting biomass, it will depend on that, and there is no fixed kind of pricing regime of biomass. That's the major challenge. I don't have exact figure, but it's definitely higher than the electrolysis, right? Could go up to around 450 to 500 at least, 500 rupees per kg. But yeah, I don't have the exact figure. Yeah, and that will depend a lot of that at what kind of biomass, at what cost you are getting.
Okay. Now there's yet another question that is asking for top 3 states in India where hydrogen projects can be planned. So this is a very wide open question.
Right. So in terms of incentive, if you see, is Odisha and AP has the highest amount of incentives, right? They have their policy up to 30%. And the best part is that if you're connected at the central, ISTS connected, right? And ISTS charge is waived off. So you can put up your plant in Rajasthan and put up the hydrogen plant in Odisha or AP. That would be the most optimum. Some of the other states are also coming up with some incentives. For example, Maharashtra has also incentives, but they have limitation of projects. The first 3 projects they would be giving and all. But as of now, AP and Odisha doesn't have any kind of cap. So these are the 2 states probably most of the developers are preferring also.
Okay. Yeah. Thank you. There's one other question now. This is for Karan from GIZ, not to you, Himadri. So, Karan, are you there to take the question?
Yes, please.
Yeah. Karan, the question is which policy instruments are most effectively help to accelerate bankable offtake between India and Germany?
Can you come again?
Which policy instruments most effectively help to accelerate bankable offtake between India and Germany?
So, as far as India, Germany, or broadly India, EU exports are concerned, while we are placed very well in terms of the strategic push which is required from government of India, but there are certain hurdles around the requirements of geographical correlation. As Himadri was saying, ISTS, while one can set up the RE asset in Rajasthan, and the electrolyzer is in Odisha or Andhra Pradesh. While it is acceptable as green hydrogen in India, but there are still interpretation issues in EU as to whether India is a single bidding zone. So that is one policy intervention which is most likely going to be addressed during the recent European Hydrogen Week. A lot of developers associations have come across, and there is one interpretation. So this is one policy level interpretation that is, once it is cleared, that and it will be quite favorable for India to start exporting from India to. Otherwise, India is very well placed with the kind of prices we have been seeing in the last fertilizer tenders. It's really remarkable. So with these policy and governmental negotiations and dialogues, I'm sure we will even manage this hurdle as well.
Yeah. I think a follow-up question again is that what is the landing cost of green ammonia at which it can be shipped to European counterparts, and what locations would be ideal?
So, as far as the location is concerned, I can give reference of the previous Hintco round for green ammonia, which was won by Fertiglobe. So they had options to either send it to Port of Rotterdam or Hamburg, but the choice was Rotterdam for that selected supplier. So it is an option which is given to the bidder. So it's mostly Rotterdam being the largest port in Europe. So people are opting, and also the infrastructure, hydrogen pipeline, backbone pipeline, which is being set across, starting from Rotterdam, which is covering mostly entire Europe. So this is some favorable condition. And also in ports like Antwerp, we are seeing cracking facilities, demo plants being set up in port of Antwerp. So these are some favorable ports as far as developers' choice is concerned. And the question about price, I mean, we have seen so much of MOUs and term sheets being signed. We have seen the landed cost of 1,000 euros per ton of ammonia in the last round, for which was won by Fertiglobe. And we have now two windows, Asian window as well as a global window. Now the prices are, we have set the benchmark quite high now with the last SECI tenders. So the prices are really competitive. So even if it is not RFNBO compliant, the only catch here is the prices that were discovered in India were not RFNBO prices. For EU, I'm sure there will be, obviously it will be more than what has been discovered here in India. But I'm sure we will see by middle of next year when the tenders will mature, and hopefully Indian companies will make it through this time in the Asian as well as the global window.
Okay, Karan. Thank you. Yeah, I think there's one last question. I think we are almost 15 minutes over time, but we'll take one last question. Asif Ahmed, how do you figure out the scope of generation of green hydrogen by the use of electricity from gas-based power plant? I think this question is for Himadri, if I'm not wrong. How do you figure out the scope of generation of green hydrogen by the use of electricity from gas-based power plant?
Right. So if you're using the hydrogen for India, right? So it has to be complied with the hydrogen certificate, I mean the hydrogen standard. So I mean, from wherever you can, if you want, you can take power, but your the emission intensity of per kg of hydrogen should be limited to 2 kg of CO2.
Yeah.
If you are within that limit, you can use some amount of gas-based power. But just one caution, if you are planning to export it to Europe, like let's say, so Europe has that RFNBO norms, you can't take any non-green power to your electrolyzer stack. You can
Yeah.
use that power for the other part, balance of plant part, but whatever power you are using for electrolyzer stack, there you can't use any gas-based power. Whether that restriction is not in India. So it depends on where you are using that hydrogen, and based on that you can use. Anyway, I mean for anything other than the electrolyzer stack, you can use it. There is no restriction for the balance of plant side.
Okay. Yeah, one last question from my side. And maybe this is jointly for Karan and for Himadri. Is banked power considered green power, right? So if we have a banking provision, Himadri, would that be considered green, and would it
In
be
India is
accepted
yes. In India it's yes if it is coming from renewable, but after 2030 it will not be accepted in EU.
Okay, after 2030 it won't be accepted in EU.
Right.
I think that answers my
Karan, I think I'm right? It's
So
2030, right?
I mean, what is happening in EU? I mean, it gives a provision initially for the 1 month, but then gradually it will be a 1 hour window for matching it. Temporal correlation is the clause, and there India is well suited because out of the criteria that I talked about initially, geographical correlation, temporal correlation, additionality. So India is okay because we have 15 minutes time matching right now as
No,
in
but
the
bank
code.
power. He's talking about bank power.
So again, it will be made possible if you through the certifying bodies, if you prove that yes, you can bank the power for like 1 month initially, and then if you can correlate later that yes, I am withdrawing that power within 1 hour or so. So that, but yes, you are right. We'll have to prove a temporal matching of within 1 hour later. We have 15 minutes blocks right now, which is well suited. 30 days banking later, you are right, will not be acceptable.
Oh, okay. Great, great. I think it's definitely a very good dialogue and discussion. The first edition definitely brought pertinent topics, and we hope to continue this dialogue on a ongoing basis with support from industry like JSL, right? And bring more pertinent topics for discussion with yeah, and consultation. That way we can help in sharing knowledge and exchanging information, right? Thank you one and all for sparing your precious time. We had over 150 registrations and close to 90 plus people attend this session, so which is commendable, and we look forward to more useful and maybe yeah, look forward to feedback from any of the participants of the current session. That way we can continue to improve what we do and deliver the next time. Yeah, thank you once again to the presenters, Karan, Himadri, Siddharth sir, and Varun, for taking your time out and sharing your valuable insights. Yeah, thank you.
Thank
you.
Srinivas.
Thank you.
Bye.
Yeah, so some questions. The recording will be made available on YouTube. We will share a link with all the people that have registered. That way you can take a look and yeah, hear to the lectures again. Yeah, thank you very much. Yeah. 1 second.